Hello everybody, today I will be doing a problem out of our textbook based on Chapter 4, Forces. Problem 4.12 states that a gusset plate is subjected to the forces shown in figure P 4.12. Find the magnitude and direction theta of the force in member B so that the plate is in equilibrium. So remember that equilibrium means that the sum of the forces in the x and the y direction are both 0. So what we're first going to want to do is make our free body diagram. For force B, it's pointing at angle theta, so we'll keep that the same. Now, force A is pointing directly downward in the negative y direction, so instead of drawing it up there, we're just going to draw it down here. And then force C is in the negative x direction, so we'll just draw that over here to make separating its components a little bit easier to see. So now we want to separate each force into their component forms so that we can determine the sum of the forces in the x and the y for the entire system. So sum of the forces on C, now you see it's only in the negative x direction, so it'll only be negative 640 newtons I. For the sum of the forces on A, it's only in the negative y direction, so we'll only have negative 310 newtons J. And for force B, we have components in the x and y direction because of the angle theta. So we'll have force BI plus force BJ because they're both in the first quadrant, making each of them positive. So when we do sum of the forces in the x, we have the negative 640 plus the force B in the x equals 0, because we're in equilibrium. Now the sum of the forces in the y equals the negative 310 plus the force B in the y equals 0. So we have FB in the I direction equals 640 newtons, and we have FB in the J direction equals 310 newtons. So remember, to find the magnitude of force B from the two components, we have to take the square root of the squares. So equals square root 640 newtons squared plus 310 newtons squared equals 711 newtons. And now, to find the angle, remember we have to do the inverse tangent of the y component divided by the x component. And it always has to be in that order, don't forget. And so we have the angle theta equals 25.8 degrees. So overall, we see that the force is 711 newtons at an angle 25.8 degrees from the x-axis. The things to remember are to make sure that the forces are pointing in the correct directions, making it easier to do the sum of the forces, and that since it's in equilibrium, the x and the y equals 0, and that when you're finding the actual force, you have to do the magnitude and then the theta with inverse tangent. I hope this helped, and thank you for watching.